event. First up is Professor Lori Krause's astronomy student, Mr. Chandler Thomas. He will be presenting on how close are we from space travel and what will get us closer to it.
All right, how's everybody doing today? All right. Today, I'll be covering space travel and what to expect. Also, my name is Chandler Thomas. Please excuse my voice. I was singing Hooked on a Feeling by Blue Suede the whole way here. Now to start off, I have a quick overview. I will be covering past examples, what we have now, and what we'll be expecting in the future, and what is hindering us today. I also want to point out this picture here. That is the Tesla that was sent up into space by SpaceX, and I was curious whether they'd send up the whole car, just bare bones, or if they send the owner's manual with it. I'm not sure. All right, to start off, I'll cover the start of the space race. Now, this ship was piloted by Yuri Gagarin, and he flew on April 12, 1961, and it was managed by the Vostok program. Now, how they flew the ship was with the R-7 Semyorka intercontinental ballistic missile. Now, during the Cold War, that was designed to go overseas and hit America. But when the Cold War ended, it was the perfect candidate to launch up Project Zenit in space. And essentially what that is, it was designed as a little spy satellite that would go over the US and observe the land and take notes. But once the Cold War ended, it proved as a perfect candidate for a shuttle for Yuri Gagarin to sit in. Now, the first method of space travel was first introduced in, 1947 by Stanislaw Yulin. And he proposed this hypothetical idea that we can travel in space with nuclear propulsion. And how it would work is right behind the pusher plate in the ship, a small directional nuclear explosion would explode forward and hit the pusher plate and generate thrust. Now the pusher plate is also there, so it dampens the field of nuclear explosion. I can imagine that's uncomfortable while sitting with that going on. But it was later put to rest because of the, it's the partial test ban that basically blocked, hey, you can't explode nuclear stuff in space. You can't do that. Because during the, if launched, it would actually kill 10 people of cancer. So that was just a big no-no. That wasn't going by. Now what we have today is, I'm using SpaceX for this example. We have the Falcon 9, which can carry up a Dragon pod. And essentially that will hold 10 or less people, and it's a touring trip. But what's really nice about the Falcon 9 is that it's made out of stainless steel, and all of the parts underneath the capsule is reusable. I will show you a video. I will actually just move on from here. But essentially in the video, they get the Falcon 9 in space, and then it detaches the first pod, and it lands, and then you see a bunch of people going crazy and enjoying the sweet victory of having it re-land. Now, I wanted to show something cool. With the Falcon Heavy, it is able to deliver 140,000 pounds up in the Earth's low orbit, which is incredible. That's a lot of weight. But also, I forgot to cover with the Falcon 9, not only can you transport people, you can also take up small satellites in space and keep them in orbit. Now, I would like to explain ion thrusters, and this ties into more of what we will expect in the future. Now, how does it work? It works, let me get my notes, excuse me. It works by ionizing a field, often xenon or argon gas, by knocking off an electron to make a positive ion. The positive ions then diffuse into a region between two charged grids that contain an electrostatic field. This accelerates the positive ions and creates thrust. Now with the neutralizing electron gun, that sprays electrons into the exhaust plume at a rate to keep the spacecraft electrically neutral. Oh, and I have one more thing. What they're currently using this for, it's you know, kind of, we're getting closer to using it for more space travel, but for now, NASA's using it to keep satellites in orbit and stay in their spot. All right, and then the last slide, simply what's hindering us from traveling to space? Well, the first issue is departure, simply just getting off Earth and into space. Second is debris. And I have a graph here that shows that China is at they hold 36% of all debris that is in space. Russia at 34, and USA at 27, which I guess that's a victory, but I don't know, it's still debris. Next is radiation. We can only handle so much. And then the fifth one is growing food in space. And actually the ISS space station was able to grow their first leaf and they ate it on the spaceship, but it's still very hard. This is the first example of it. Next, simply put, if you're in space for a while, you're going to turn it too much. You have to work out, but you can only do that for so long. Last, crashing is simply not an option. The only way we can have space travel be successful is if we can figure out a way to slow ourselves down and break in space. We can't just, hit Mars and like, oh, we made it. But, that's what we need to figure out. All right. Overall, once we figure out, how to slow down the ship, we figure out all the 1 through 7 I just listed, and we take advantage of ion thrusters, space travel will be in our grips. But it's not too close. We do have to wait. What we do have is SpaceX, and that's more the here and now. But ion thrusters is the here and later. And here's actually the leaf that is on the ISS space station. I just wanted to show you that picture. But does anybody have questions? Yes?
Is there do they have any plans to limit debris in space? Or is it just constantly being added to as we move up there?
I'm not sure. I mean, it was, I would love to answer that, and that's definitely a great question. I want to say that they do have plans to get rid of the debris and really limit it, but it was more outside of my research, but I love the question. Anybody else? Yes?
When did that happen with the plants? How recent?
It was about, I think it was within these couple of years, I believe it happened. I actually have the video on the other side, was I having a little trouble. Sorry. Any other questions? All right. Oh, yes.
Okay, sorry. Could funding be an issue too, or just like being able to fund it to be able to do all this?
Well, what's the beauty about SpaceX is, since they're reusing parts, it's cutting costs significantly. I actually, if you want, I can go back and show you the pricing of how much it costs. Let's see, it's right here. It costs $62 million to get the Falcon 9 in space, and then about $90 million to get the Falcon Heavy. All right. Thank you so much. I appreciate all and every one of you that came out today. Thank you.